Hello everyone, my name's Mariana and today I'm going to be discussing an article I found in Science News magazine titled Brain Zapping Implants That Fight Depression Are Inching Closer to Reality. This was written by Laura Sanders, February 10th, 2019. So this article looks at the potential of using deep brain stimulation as a means of treating people with severe baseline depression. Now, how did they come about this idea? Well, researchers were looking at patients with epilepsy. They had implanted hundreds of tiny electrodes into the outer layer of the brain, and they were testing various regions of that person's brain. Now, after targeting a region behind the eyes, more specifically the orbitofrontal cortex, the woman they were testing responded saying that she felt calmer in her nerves. They then went on to test other patients where they got similar responses. One person said they felt more positive, another said they felt calmer and they felt more energetic and they felt more alive. This development in our understanding regarding treatments for depression is changing our outlook on how we approach this mood disorder. Now, Sigmund Freud in 1917 told us the disorder was to blame on repressed anger and bad parenting. We later then came to a more widely accepted concept known as the chemical imbalance concept, where we administer oral medication in order to alter afferent neurons and their signals regarding the neurotransmitters that go from synapse to synapse, and essentially looking at the brain from a chemical perspective. However, this is making us look at the brain electrically. How can we alter the brain via its means of communication, which is electric flow through axons and neurons? Before I get into the details of deep brain stimulation and its relation to treatment-resistant depression, I want to show everyone an example of how electricity is actually at work in our brains, in particular along an axon. So I've printed out a diagram, the 3 stages of an action potential traveling down an axon. So it's a voltage-gated sodium channel that maintains the amplitude of an action potential. So this voltage-gated channel is triggered when it is depolarized, reaches threshold. It then opens and ions, in this case Na, flood into the axon. So it goes from here to this stage. Then this in turn depolarizes the next voltage-gated channel and the process repeats itself down the axon. This is indicative of how electrical signals are transferred down an axon and how the brain is able to communicate between various regions through the white matter and through axons and neurons present within the brain. Now you're probably thinking, what actually is DBS and how is it administered? What is it going to entail and how is it related to treatment of depression? Now, DBS is a modern application of electrical stimulation that involves neuromodulation therapy administered to the most effective part of the brain in terms of what you are trying to treat. For Parkinson's disease, it's below the cerebrum. In this case, scientists are looking at the orbitofrontal cortex as the most effective region that will be able to regulate moods and assist this device in allowing the electricity of the brain to be functioning properly and the circuits to not dysfunction as they are in a patient with depression. To further characterize the neurophysiological effects of stimulation to the orbitofrontal cortex, and short for that is OFC, by the way, researchers probed for changes in cortical excitability. They did this by analyzing potentials evoked by current pulses that were administered to the target area, which was just here, immediately before and after continuous stimulation. Now, they found that unilateral stimulation to the OFC resulted in acute dose-dependent mood improvement in the subjects with moderate to severe depression. They also found stimulation suppressed low frequency power in OFC, mirroring neurophysiological features that were associated with positive mood states in natural mood fluctuations. And finally, what does the future look like for this neurophysiological development? Well, the pros regarding this medical application is there are no systemic side effects because it's directly administered to the brain. Unlike oral medication, where it has to be taken orally, passed through the body, and that's how its effect is done, is by having to go through the rest of your body to then get to the CNS, the central nervous system. This doesn't have those symptoms. So directly applied to the brain, the electricity is turned on and off at the person's wish, and that's all it comes down to. There is no residue that the electricity leaves, and the person doesn't have to, deal with the side effects of medication. The cons, however, have been that 2 large industry-funded clinical trials haven't been so positive. However, hopefully researchers continue to look into this to fill the gap for the patients who have treatment-resistant depression.